Hey guys, welcome back. By now, you're quite familiar with HDFS. It is now time to learn about MapReduce. So in this lesson, we're going to learn about the basic concepts of MapReduce. But I'm not going to bore you with the word count problem. We're going to learn the MapReduce concept using a fun example. Ready? Okay, let's pick a state, California. Imagine for a second, the governor of California comes up to you and make you the head of Census Bureau for the state of California. And you are tasked with finding the population of all cities in California. You have all the resources you want, but you have only 4 months to finish the task. Think about this for a second. How would you proceed with this task? Remember, you can have all the resources you want. What would be your process? Calculating the population of all cities for a big state like California is not an easy task for any one person, right? So the sensible thing to do is to divide the state by city and make individuals in charge of each city to calculate the population of each city he is in charge of. Just for illustration purpose, let's focus on only 3 cities: San Francisco, San Jose, and LA. Person 1 will be in charge for SFO. Person 2 will be in charge for San Jose. And person 3 will be in charge of LA. Okay, so far so good, right? You have divided the California state into cities, and each city is assigned to a person. And he is responsible for finding the population of the assigned city. You now need to give instructions to each person on what they have to do. So you ask each person to go to a home, knock on the door, and when someone answers the door, ask how many people live in the home and note it down. You give them specific instruction on what each person should note down. You're instructing each one to note down the city they are responsible for and the number of people live in the home. Then the person has to go to the next home and repeat the same process until he covers all homes in the assigned city. Make sense? So, for a person who covers SFO, he goes to first home. There are 5 people in the home, so he note down SFO 5. 3 people are living in the second home, so he note down SFO 3. You get the idea, right? It is a classic divide and conquer approach. Same instructions will be carried out by everyone involved. Person 2 will go to San Jose, and person 2 will do the same in LA. When each person is done with their assigned city, you ask them to submit their results to the state's headquarters. You'll have a person in the headquarters to receive the results from all cities and aggregate them by city to come up with population of each city for the entire state. Very simple process, right? So 4 months in, with this strategy, you're able to calculate the population of California. The governor who assigned this task to you is so happy, right? Next year around, you're asked to do the same job. You have all the resources you want, but this time you have 2 months to finish the task. What would you do? Remember, you have all the resources you want, so you would simply double the number of people to perform the task. You will divide SFO into 2 divisions and add 1 person to each division. And you will do the same thing for San Jose and same for LA. Each person responsible for a division will perform the same task as before. You can also do the same thing at the headquarters. Let's divide the headquarters into 2. California headquarters 1 and California headquarters 2. And 1 person to each division. Perfect. With twice as much people, you can finish the task in half the time. But there is one small problem. You want the census takers for SFO, that is SFO1 and SFO2, send their results to either California headquarters 1 or headquarters 2. You don't want SFO1 sending results to California headquarters 1 and SFO2 sending their results to California headquarters 2, because this would result in population count for SFO divided between headquarters 1 and 2. That is not ideal, right? Because we want consolidated population count by city, not partial counts. So what we can do? Simple. We can instruct census takers in SFO 1 and 2 to send their results to either headquarters 1 or headquarters 2. Similarly, we should instruct census takers for San Jose and LA. They should either send it to headquarters 1 or 2. Problem solved. You try with this model and again you did it. You were able to complete the census calculation in 2 months. If next year, if you were asked to do the same thing in a month, you know exactly what to do. And you can simply double the resources and apply your model, and it will work like a charm. You now have a good enough model. Not only the model works, but it also can scale. That is it. The model you have here is called MapReduce. MapReduce is a programming model for distributed computing. It is not a programming language. It is a programming model which you can use to process huge data sets in a distributed fashion. Now let's look at the phases involved in MapReduce. The phase where individuals collect the population of their assigned city or part of the city is called the map phase. The individual person involved in the actual calculation is called the mapper. And the city or the part of the city he is working with is known as the input split. The output from each mapper is a key value pair. As you can see, the key is SFO, the value is 5, or the key is San Jose, the value is 2. The phase where you aggregate the intermediate results from each city or mappers in the headquarters is called the reduce phase. And the individuals who work in the headquarters are known as the reducers because they reduce or consolidate the output from many different mappers. Each reducer will produce a result set. The phase in which the values from the different mappers are copied or transferred to reducers is known as the shuffle phase. The shuffle phase comes in between map and the reduce phase. So, the map phase, shuffle phase, and reduce phase are the 3 phases of MapReduce. We'll look closer into each phase in the next lesson, where we'll talk more about entities like combiner, partitioner, etc. Okay, so let's summarize what we learned about MapReduce. MapReduce is a distributed programming model for processing large data sets. So this concept was conceived at Google, and Hadoop's adapt this programming model. It can be implemented in any programming language, and Hadoop supports a lot of programming language to write MapReduce programs. You can write a MapReduce program in Scala, Python, C++, and of course Java. MapReduce is not a programming language. It is a programming model. So always keep that in mind. Of course, Hadoop implements MapReduce. So the MapReduce system in Hadoop manages the communications, data transfer, parallel execution across the distributed servers or nodes. So in this lesson, you got introduced to the concept of MapReduce, and you also know the phases involved in MapReduce. So in our next lesson, we'll go over each phases in detail. And then we'll try to write a MapReduce program in Java. One step at a time, okay? With that, let's wrap this lesson. See you in the next lesson.